I found a few things that were sort of interesting about this power supply board, so I thought I'd make a little side video to talk about it. The first thing, which is pretty obvious, is that this power supply board is split into two distinct sections. One is the high voltage section, and the other is the low voltage output section. And they're separated by this piece of the PCB that doesn't have any traces going over it, and is also drilled full of holes. So if you take a look, the wires that are connected directly to the mains are going to that high voltage side, which also has the fuse and the mains voltage selection switch. And the low voltage end here has all my power supply outputs on it. And the two sections are connected through these transformers there, which step down the voltage and also isolate the two sections from each other. So I thought that was kind of interesting. I'm not entirely sure what these holes are for. Maybe it improves isolation or something. If you know why those are there, go ahead and speak up in the comment section down below. Something else that stands out as being kind of interesting is this big massive blob of solder right here. This is actually the ground rail of the output of the power supply. Now the reason it's got this huge glob of solder on it, and it looks like it even has a couple wires underneath there too, is because it needs to carry a whole bunch of current. Let's take a look at the case, which has the current ratings for all the rails. It's 28 amps for the plus 3.3 volts, 30 amps at 5 volts, 34 amps at 12 volts. Already that's getting pretty close to 100 amps. And since the ground is shared by all of the voltage outputs, it's going to be carrying all of that current. So this guy needs to handle a lot. And putting a huge glob of solder on there lowers the resistance and increases the maximum current capacity of that trace. That's a neat little trick that's done a lot in power supplies, which is a good low-cost way of increasing the current capacity. There are a couple of good videos about this on Mike's Electric Stuff in the EEV blog, so I'll go ahead and leave those down below, so you can go ahead and check those out too. And a couple more things about grounding the supply. I mentioned in a previous video that the connection between the output ground and the mains ground, that third prong, was done through the case. And you can see here these little solder dots around the screw holes are what was making that connection. So if we put the multimeter on beep mode and probe each of these guys, we can see that they're connected directly to the output ground. So these two screw holes were connecting the output ground to the case and then to the mains earth. But then we also have these two screw holes down here, and they're on the high voltage section of the board, so they are not connected at all to the output ground. So no connection between those and the output ground. In fact, they're not even connected to each other. They're completely isolated. You can see there's no copper going between those. If you take a look at the top side of the board, you can see that they have some capacitors going between those ground points and some other nodes in the circuit. So these are probably some filtering or decoupling. That might actually be pretty important because having a stable ground here might be important for keeping a stable voltage at some points in this high voltage circuit, which might in turn be important for keeping some voltages stable on the low voltage part of the circuit. And since these two ground points are not connected at all to the output ground, it's at the very least not going to hurt anything to connect these to mains earth. Because I can connect these to mains earth and still have an isolated ground at the output. And since it's probably important to connect these to mains earth, I'm going to go ahead and do that anyway. So if you're doing a project like this, make sure you take a look at all the points that were originally connected to mains earth and check to see if they're actually important. If they're not directly connected to the output ground, then you might as well connect them to mains earth anyway, since it's not going to hurt anything. Now, while I'm on the topic of grounding, I found another video where some guy stacked a whole bunch of these ATX power supplies together and made a single really high voltage power supply, which is pretty cool. He talks a little bit about grounding too, so I'll go ahead and leave that in the description down there, so check that out too. So that's it for this video, just a few short things that I found interesting about this board.